Chapter 6. The Disk That Follows You Around. Tom had a red pen and a habit that made Leo nervous. Every Saturday morning, Tom printed the AWS console summary, running instances, storage volumes, attached disks, and went through it line by line. He had been doing this since week 2. He called it the ledger. Leo called it the thing Tom does that makes Leo feel like he's done something wrong. That Saturday, Tom circled something and left the printout on Maya's desk without a word. She found it Monday morning. 1 circle, 1 note in the margin, 3 words. Everything, 1 machine, the web server, the database. All the customer records, 2 months of order history, all of it running on a single EC2 instance. What happens to the database if the instance crashes? Maya asked, the printout in her hand. It crashes too, Leo said. And the data? Depends on how the database stores it. That depends was the problem. How EC2 instances store data. When an EC2 instance runs, its operating system lives somewhere on a disk. That disk is called the root volume. By default, this is an EBS volume, even when you don't think about it. But there's something else. EC2 instances also have instant store storage. Instant store is temporary storage physically attached to the underlying hardware that runs your virtual machine. It's extremely fast, faster than almost any other storage option in AWS. But it comes with a catch. Instant store is ephemeral. When the instance stops or is terminated, instant store data is gone, permanently, not recoverable. AWS doesn't warn you very loudly about this, which is how teams discover it, by losing data. Instant store is appropriate for caches, temporary processing files, and scratch space, never for data you care about. EBS, the persistent disk. Amazon EBS Elastic Block Store is persistent block storage for EC2 instances. Block storage means it behaves like a real hard drive. Your operating system can create file systems on it, read and write arbitrary bytes at arbitrary positions, run databases on it, and treat it exactly like an attached disk. The key properties: persistent. Unlike Instant Store, EBS volumes survive instance stops, starts, and even instance termination, depending on configuration. The data stays on the volume even when no instance is using it. Attachable and detachable. An EBS volume can be detached from one instance and attached to another. If you need to migrate data or recover from a failed instance, you can detach the volume and reattach it elsewhere. Single attachment, mostly. By default, an EBS volume is attached to exactly one EC2 instance at a time. A single instance can have multiple EBS volumes, but a single EBS volume can't be mounted by multiple instances simultaneously, with one exception: EBS multi-attach, which has limited use cases and important restrictions. The analogy: EBS is an external hard drive that you plug into a laptop. The laptop EC2 instance can read and write to it. When you're done, you can unplug it and plug it into a different laptop. EBS volume types. Not all EBS volumes are the same. AWS offers several types with different performance and cost profiles. GP3, General Purpose SSD. The default choice for most workloads. Good balance of performance and price. Suitable for boot volumes, small databases, and development environments. IO2, Provisioned IOPS SSD. High performance option for IO-intensive workloads. You specify how many IO operations per second, IOPS you need, and AWS guarantees that performance. Appropriate for large production databases. ST1, Throughput Optimized HDD. Magnetic storage optimized for large sequential reads and writes. Lower cost than SSD, but slower for random I/O. Good for data warehousing and log processing. SC1, Cold HDD. The cheapest EBS option, for data accessed infrequently. Not appropriate for anything time-sensitive. The exam doesn't require you to memorize all types. It does test your ability to match requirements to the right type. IOPS requirements: IO2, cost-sensitive sequential workloads. ST1, General Web Applications. GP3, EBS snapshots, the backup. Here's something that saves companies regularly. An EBS snapshot is a point-in-time backup of an EBS volume, stored in S3, that you access it through the EBS interface, not directly through S3. Snapshots are incremental. The first snapshot captures the full volume. Subsequent snapshots only store what changed since the last one. You can create a new EBS volume from a snapshot, restoring to a point in time before a database corruption, a bad deployment, or an accidental deletion. You should automate snapshots. AWS provides Amazon Data Lifecycle Manager for this purpose. Define a policy, take a snapshot every 6 hours, keep the last 7 days, and it runs automatically. Priya had this set up before the database even went into production. Leo had not thought of it. EFS, the shared filing cabinet. EBS is a disk attached to one instance. What if multiple instances need to access the same files simultaneously? Enter Amazon EFS, Elastic File System. EFS is a managed network file system. Multiple EC2 instances can mount the same EFS file system at the same time and read-write to shared files. This is the key capability that EBS doesn't provide. Think of it this way. EBS is an external hard drive plugged into one laptop. Only that laptop can use it at a time. EFS is a filing cabinet in the center of an office. Any team member can walk up, open a drawer, read a file, put something back. Multiple people simultaneously accessing the same storage. When do you need EFS? When multiple EC2 instances need to share files, content management systems, shared configuration files, shared media libraries. When you have a horizontally scaled application where all instances need access to the same data. When you need a persistent file system that survives instance failures. EFS versus S3. EFS is a file system. Folders, files, permissions, locking. S3 is object storage. Upload, download, no file system semantics. EFS is much more expensive than S3. Use S3 for files that are stored and retrieved whole. Use EFS for files that applications actively read and write through standard file system operations. Choosing the right storage. By now you've seen 3 types of storage in AWS. Let's make the decision crisp. Need, storage type. Database needs persistent fast disk, EBS, GP3, or IO2. Multiple servers need shared files. EFS, files, backups, images, large objects. S3, temporary computation scratch space, instance store, long-term archives at minimum cost. S3, Glacier. Getting this decision right matters. Using S3 where you need EFS adds operational complexity. Using EBS where you need EFS causes failures when you scale. Instance store where you need persistence loses data. Priya printed this table and stuck it on the wall. Every time we add a storage requirement, she said, we start here. Strengths and limitations. EBS strengths. Persistent fast block storage for EC2. Snapshots for point-in-time backup and recovery. Multiple performance tiers for different workloads. Encryption at rest supported natively. EBS limitations. Attached to one instance at a time, with minor exceptions. In the same AZ as the EC2 instance, copying to another AZ requires a snapshot. You pay for provisioned storage, not just what you use. EFS strengths. Multi-instant shared file system. Native NFS protocol. Scales automatically. You don't provision capacity. Accessible across AZs within a region. EFS limitations. More expensive than S3 per GB. Higher latency than EBS for random I/O. Not available in all regions. Summary. Instance store is temporary fast storage physically attached to the host. Data is lost when the instance stops or terminates. For scratch space only. EBS, Elastic Block Store, is persistent block storage for a single EC2 instance. It survives instance stops. It can be snapshotted for backup. Choose the right volume type. GP3 for general use, IO2 for high IOPS requirements. EFS, Elastic File System, is a shared network file system that multiple instances can mount simultaneously. Use it when multiple servers need access to the same files. Match the storage type to the requirement. Database EBS, shared files EFS, objects backups S3, archives S3 Glacier. Exam tips SAA CO3. Domain 3, Task 3.1, Storage Solutions. EBS volumes live in one AZ. They can only be attached to an instance in the same AZ. To use an EBS volume in a different AZ, you create a snapshot and restore it in the target AZ. EBS snapshots are incremental and stored in S3. First snapshot is full. Subsequent ones only store changes. You can copy snapshots to other regions for disaster recovery. EFS is cross-AZ. Multiple instances in different AZs within the same region can mount the same EFS file system. This is a key differentiator from EBS. When an exam scenario says web application with shared content, or multiple instances accessing the same files, think EFS. When it says database storage, or persistent disk for one server, think EBS. Instance stored data survives a reboot but not a stop or termination. A question might describe data that disappears after the instance is stopped. That's instance store in play. Exercise 1. Recall. In your own words, what is the difference between EBS and EFS? When would you choose one over the other? Hint. Think about whether one instance or multiple instances need to access the storage at the same time. Exercise 2. Exam practice scenario. A company runs a web application across 4 EC2 instances behind a load balancer. Users can upload profile photos. All 4 instances must be able to serve any user's photo immediately after it's uploaded, regardless of which instance handled the upload. The team needs persistent shared file storage. Which storage solution best meets their requirements? A. Attach an EBS GP3 volume to each EC2 instance and sync files between them using a cron job. B. Store photos directly on the EC2 instance's instance store. C. Use Amazon EFS mounted on all 4 EC2 instances simultaneously. D. Store photos in S3 and access them directly from the application code. Hint 1. The requirement is all 4 instances must serve any photo. Which options make a file immediately visible to all instances? Hint 2. Instance store is ephemeral. EBS can't be mounted on multiple instances simultaneously. That narrows it down. Hint 3. Both C and D could theoretically work. Which is more appropriate for a case where the application needs to access photos through file system operations versus HTTP requests? Answer. D. Explanation. Storing photos in S3 and serving them via URL is the architecturally correct choice for a web application. Uploaded photos are immediately accessible from any server and from any browser through S3's URL. S3 is designed for exactly this use case, storing user-uploaded files at scale with high availability and zero management overhead. Note, CEFS would technically work, but S3 is the preferred pattern for user-uploaded binary files in web applications because it's cheaper, more scalable, and serves files over HTTP directly without the application acting as a proxy. Why not A? Syncing files via cron job creates race conditions and consistency problems. Between uploads and the next sync, files would be missing on other instances. Why not B? Instance stored data is lost when the instance is stopped or terminated. Photos would disappear. Why not C? EFS is the right answer if the application meets file system semantics, e.g., a CMS that modifies files in place. For user-uploaded photos served over the web, S3 is simpler, cheaper, and more appropriate. SAACO3 Domain 3 Task 3.1 Exercise 3 Architecture Challenge Optional. Nimbus is adding a new feature. Restaurant owners can upload PDF menus that are then parsed and used to populate the Nimbus database. The PDF processing job runs on a fleet of EC2 instances that need to A. Read the uploaded PDF, B. Write temporary processing files, C. Write the parsed output. Which storage services would you use for each of these 3 steps and why? There is no single correct answer. Focus on matching storage type to the characteristics of each step. Post-credit scene. That afternoon, Nimbus separated their storage properly. The database got its own EBS volume with automated snapshots. The menu photos moved to S3. The EC2 instance finally had room to breathe. Leo ran a load test. The site handled 200 concurrent users without breaking a sweat. Tom looked at the bill. The EBS volume was adding $8 a month. He wrote it down. I keep adding things to this bill, he said. When does it balance out? When we stop having outages, Maya said. Every outage costs more than the prevention. Tom did not look convinced. He would be eventually. 3 days later, a restaurant owner on the platform tried to place an order and got an error. Maya checked the logs. The database was there. The application was running. But 20 simultaneous users were all trying to read the menu at once, and each one was hitting the database. Every page load is a database query, Leo said. Every single one. Priya was already Googling something. In the next chapter, what happens when more customers arrive than the server can handle?